Welcome, Sheldon. The floor is yours.
Hello there. Thank you very much. Give me 1 second while I get situated with my PowerPoint. All right. Can you all see me and hear me loud and clear?
Yes, sir, we see you and your presentation.
Awesome, wonderful. Thank you for the last minute panelist addition here. I'm obviously not Zach Schumann. He's my supervisor here at Woolpert. We are just he's got another commitment, and I will be filling in. So a little bit of background about myself. My name is Sheldon Menezes. I lead up Woolpert's Advanced Air Mobility R&D practice. So we focus a lot on AAM and UAS research for the Federal Aviation Administration for several state DOTs and several airports in the United States. Our firm has worked with the FAA in the publication of Engineering Brief 105. We've helped several states and state DOTs develop their own advanced air mobility strategic plans, and we're helping airports understand how they would integrate AAM into their operations. The presentation that I'm filling on for today is going to cover the data behind vertiports, the data that goes into establishing and operating a vertiport. So, you all have been sitting through a variety of presentations today that cover what AAM is. What I want to discuss is perhaps the ecosystem that makes up this emerging industry. So you've got not only the OEM, but also the maintenance facility, the operator, the infrastructure general contractor that puts the vertiport together, the operator that manages and takes care of the day-to-day operations of the vertiport, the utility company, the communications company, the UTM, unmanned traffic management solution that facilitates the airspace operations, the corporate real estate, the multimodal transportation that allows for various nodes to come together at the vertiport, your local regulators and your government, your state and local government, your federal government, as well as the end users, all make up the AAM ecosystem. What we want to get into is the data that is required to ensure that all these different entities within the advanced air mobility ecosystem communicate together to facilitate the operation. It's important to understand the crawl, walk, run nature of this industry. So, as advanced air mobility has initial implementation, initial entry into service, we'll see operations with a pilot on board in, visual conditions. What's important to understand is that these aircraft are going to operate within the existing air traffic management system and using existing infrastructure. As we move from that crawl phase into the walk or even into the run phase, future operations will consider autonomy, more complex operations in instrument conditions, advanced air traffic systems, and expanded vertiports, expanded infrastructure like vertiports or standalone infrastructure um, um, that that allows for this industry to take off at its high tempo, high volume. Um, there is much to consider when discussing a vertiport integration or vertiport planning. Let's start with the airside, landside engineering. There's hard infrastructure as well as supporting soft infrastructure as well. You want to consider the vertiport regulations. If it's in the United States, it's Engineering Brief 105. ICAO and EASA have different regulations. ASTM has a standard for vertiport design. It's important to consider what standard you're building your vertiport to. It's also important to understand, your aircraft rescue and firefighting. A lot of these electric aircraft operate with lithium-ion batteries, and guidance for putting out a lithium-ion fire is still emerging. To put out a Tesla battery fire, it's 1,000 gallons of water and a firefighting staff that's, with this for hours on end until the battery thermal runway is complete. For electric aircraft, it is unknown, and it is important to consider your fire and rescue as part of your vertiport design. Then it's also important to consider the terminal design, the facility that's needed, the architectural and building components for the vertiport itself, the ground transportation and multimodal network that make up the multimodal nodes as part of your transportation system in a city or in a state. It's then important to consider, digital terrain mapping and the topography and obstacles surrounding the facility to understand what are the low altitude obstacles in the area, what are the pertinent safety critical data around the vertiport that's needed, and who is going to take the responsibility of mapping the topography, understanding the geospatial data that makes up the obstacles surrounding a vertiport, and who is going to be responsible for maintaining that database and updating that database as conditions may change around the airport or vertiport. It's also important to consider utilities, both from an electric standpoint, from a water, sewer, as well as telecommunications and communications, Wi-Fi, fiber internet. All of this is going to be required to facilitate advanced air mobility and eVTOL operations at a vertiport. Finally, considering the nav aids, the airspace, your approach lighting, your obstacle surfaces, your airspace needs are an important consideration as part of the design. Finally, the safety, security, sustainability, and resiliency, as well as understanding what landscaping, public viewing areas, green spaces may be needed, all need to come together in a planning effort while developing your vertiport concepts. Um, the data behind a vertiport can simply be organized into the infrastructure needs, the geospatial needs, and the operational needs. So what that means is from an infrastructure perspective, your planning needs, you need to understand when planning a vertiport, you need to understand the land use surrounding the area, the zoning surrounding the area. If it's on or near an airport, the airport planning documents, the airport master plan documents. If it's in a dense urban environment, understanding what's the city planning and the city master plan look like. And the vertiport planning process, the vertiport design process should really be complementing all of these other planning documents, all of these other planning studies that may exist in the ecosystem, right? Moving on from planning, you would then get into the engineering drawing and the engineering design. That's where it's important to consider the standards against which the vertiport is going to be built. I'm based in the United States. Vertiports in the US would have to be built to the existing interim guidance from the Federal Aviation Administration is, again, Engineering Brief 105. There will be a future combined vertical lift advisory circular that comes out, and a vertiport would then have to be built to that standard that considers, what the TLOF, which is the touchdown liftoff area, the FADO, the final approach area, the safety area, and what downwash caution areas need to look like. You then want to consider multimodal access, be it rail, roadways, bus, or if it's a seaport or a cruise port, what other multimodal nodes may exist within the ecosystem that needs to be planned into the vertiport infrastructure planning process. In this category, it's also really important to consider an alternative landing site. So if you're planning a vertiport, you also want to consider planning an alternative landing site in the event of an emergency, in the event of an irregular operation, in the event there's some sort of malfunction. Having an understanding, having a planning of what the alternative landing sites look like, where that may be located, is a critical aspect of the safety of the operation, not only for the operator and the vertiport itself, but for the community at large. Following the infrastructure category, we've got geospatial data needs. It's important to understand the sheer large scale obstacle data identification that would need to be done surrounding a vertiport that could take form of either a citywide or a statewide, obstacle inventory, a LiDAR data collection. But it's important to, again, have that continuous database management or crowdsource that database management to ensure that the geospatial data surrounding a vertiport is being updated in near real time to then facilitate those operations. So from an operational perspective, the data that's important to consider is the vehicle position. So for the aircraft itself, it's important to know the ADS-B data, the specific location of the aircraft as it operates in and around the vertiport itself, the vertiport management system. This is your UTM management system, a flight scheduling system, and then whatever technologies and whatever data is going to be needed to facilitate autonomous operations as we get to that more mature stage of AAM are all data needs that need to be considered while considering your vertiport planning process. Here's an example of land use data as well as topography data that's being considered as part of a vertiport siting study, especially with the approach and departure corridors into that vertiport. The next example that's here on the screen is the aeronautical data that goes into the FAA ADIP portal. So that's the Aeronautical Data and Information portal that the FAA mandates all heliports and vertiports maintain this data in a database. The example that is on the screen here is a vertiport siting study in and around a university in the Dayton, Ohio region. And what we've done is on the slide on the top left here is consider 5 or 6 different sites at an airport at this location where a vertiport may exist, and then place engineering brief 105A sized vertiport and consider what the approach and departures look like to understand where obstacles to the approach and departures into that vertiport may impact. And that has helped us cite 6 different alternatives to a vertiport at a location and end up with one preferred alternative as seen on the screen here. Finally, it's important to consider multimodal connectivity. The examples that you're seeing on the screen here are an example of a vertiport that's being integrated into a comprehensive airport master plan update for the Fort Lauderdale Hollywood International Airport. So this is one of the top 40 airports in the US, very busy airport, and the planning documents that you've seen on the right side here consider the placement of a vertiport as well as 4 parking areas on top of a intermodal center at an upcoming intermodal center. So this is a rendering for what that intermodal center is going to look like. It's placed right over here on the other side of the access road to the terminal building. What's happening here is this is going to be a center that allows for a rental car facility, buses and trains to come to the airport, and on the rooftop, we've placed, again, planning concepts for a vertiport, and we're working towards bringing advanced air mobility planning into the airport master planning process. So little snapshot of this was a year-long planning effort. We've just delivered these plans to the Broward County Aviation Division, who are the sponsors of the Fort Lauderdale Airport. That was it that my colleague Zach had put together, and again, I'm filling in for him here. Feel free to reach out to me. My email is up on the screen, or feel free to connect with me on LinkedIn, and happy to continue the discussion if there are any specific questions. Thank you.
Thank you very much. We actually are slightly ahead of time. We have about 4 minutes before the closing today. If anybody has any questions, please put them either in the chat or in the Q&A box for this gentleman to answer.
Yeah, there's one in the chat here about if a vertiport will have its own ground handling units or will it be coordinated with the airport ground handling units. So that's going to vary depending on who the end operator is, right? So if it's a vertiport being co-located with, let's say, a fixed-based operator at an airport, the onus of having those ground service equipment, the ground handling units, would fall on the FBO or the operator itself. If it was an operation that is not unique to other operators and is just a single operator, like a Joby aircraft or a Beta aircraft, then again the ground handling would be contingent on who the specific operator is. But I would say the answer to your question that was posted in the chat is going to vary based on the use case, the location, and the application.
There is another question from someone named Ayal. Is there a vertiport traffic management system, for example, like a local UTM?
There are definitely concepts for, traffic management systems that are out there. For example, in the Fort Lauderdale example that I had shared, that's at an airport, and that would be integrated into the local air traffic management system. So as part of that planning effort that we had considered, we brought in representatives from the air traffic control tower and understood what would be the impact of bringing in, an aircraft. And all our planning ensured that we did not want to impact legacy aviation operations. And for at an airport, that vertiport traffic management system would just fall right into the comprehensive airports air traffic management system. For a much more localized facility in a in let's say an urban environment, there would have to be a specific traffic management system in place, and there are certain emerging solutions on the market that offer such a service by pulling in ADS-B data, having ground-based radar that allows for again additional detection. So
Perfect.
yep.
I think that's all the time we have. There is another closing statement from Molly. So thank you so much for your time, and thank you for stepping in for Mr. Schuman. Next up,